My name is Ria Bhatia. I'm part of Microsoft and Azure, and I specifically work on a cool project called Virtual Kubelet. If you guys have heard of it, it's an open source project. We'll actually get into some of the details in this talk today. But what I'm here to talk to you guys about is scaling in Kubernetes. So we'll basically go through the basics of what it means to scale in Kubernetes today, and then I will give you kind of an insight into like how us as Azure, how we're thinking about scaling, and then kind of how like the community in general is thinking about scaling for the future. So let's get started with my awful graphics. So the cluster autoscaler is really simple. All it means is if you have a bunch of nodes in your cluster in Kubernetes and those nodes are full with a bunch of pods, you need to be able to scale those nodes up. So the cluster autoscaler allows you to scale those nodes up automatically. It's something that you can get, for example, in GKE automatically. It's something that Azure will be offering in the future as an automatic cluster autoscaler. But you can also pave it yourself in your own clusters that you have in Kubernetes. So here's the fun graphic. It just literally adds nodes. It's a simple, basic building block of how you start to scale in a cluster, is scaling with nodes. So then when we get into more of the specifics of it, it's supported with 1,000 nodes running 30 pods each. That's what it's been tested against. And you can get these all from the Kubernetes docs too. And it scales when pods have been failed to run the cluster due to insufficient resources. There's also nodes that are in the cluster that maybe were underutilized for an extended period of time. And then those pods can be placed on other existing nodes, and then the node can spin down. So it does both for you. It'll scale up, and it will scale down. So this is another example or awful animation of mine of how you would get those waiting pods and how they would schedule. So you have a bunch of pods, maybe they're in a waiting state, and how they would schedule back on to build a full node. It's basically the premise. Pretend all those waiting pods weren't able to get scheduled there, and then they all automatically moved over to the right. This is the wordiest slide that you will see today. The virtual pod autoscaler. So this is an interesting one. It's still in beta, but we're getting closer to how we get your applications and your pods suited for the right amount of memory or CPU that you need. People are just bad at resizing their images. We don't really know how much CPU we need, how much memory we need, until we experiment a little bit more, until we actually get into the details of what my application's doing, like when I have a lot of customer traffic or when I don't. So this comes into play because it'll dynamically resize it for you, so you don't have to put in the guesswork for this is the amount of cores I need or this is the amount of memory that I need. But also, there's a tidbit, it shouldn't be used in conjunction with the HPA based on CPU or memory metrics, because what will end up happening is both these things are triggered on CPU and memory, and then you'll get a weird thing where your pods will start to resize, but then at the same time, your pods will also start to replicate, and then people don't know what's supposed to happen there. So I think there's a lot of work that needs to go into figuring out that model and flesh that out a little bit more. And then the horizontal pod autoscaler. This is something that we'll focus on a lot in this talk. And basically, it also scales pods on custom metrics or CPU and memory. So one of the custom metrics that I think is really useful is requests per second. So if you have a lot of customer traffic for a website, for example, or there's a lot of people paying some sort of front end, that's when you would be able to scale your pods based on if I want 10 requests per pod or if I want 100. And at the same time, you're gonna have to do a little bit of guesswork of how much your container can hold. All of these things are just basic numbers like, okay, I want maybe only 100 requests or 10. But then you actually have to go still through the basics of, is my pod gonna fail if I have 150 requests or will it fail on 100? And that's unfortunate because I think that's where the community will go to figuring out in the future. And here's another little graphic of what this one does. It literally just adds pods to a node. So if you have an example deployment, you could say, hey, I want to scale this up to X amount of replicas. That's what this is doing. It's scaling it up to X amount of replicas for that specific deployment. So there you go. And now I'm going to get into something. These are pretty simple concepts. I think the the way that we scale today, you scale on nodes and pods are pretty ingrained in people's minds, I think, is at this point. What I want to start talking about is, what if you wanted to, when you're thinking about scaling, the reason you want to scale is because you're probably spending a lot of money on infrastructure. You probably have over-provisioned your clusters, so you have a bunch of nodes and a bunch of underutilized compute. And that's why we end up scaling. That's really the reason why we want to do those things. So if we're really talking about money and underutilized resources, that's when I want to bring in another concept of scaling, and that's just scaling with pods. And that's when I need to talk to you guys about ACI. So I've done a similar version of this talk at LinuxCon China, and it went pretty well. It was pretty cool. But this is part of the slides from it, so thankfully they're translated. So we have ACI, Azure Container Instances. It's a managed service by Azure, by Microsoft. There's also other services that Alibaba has, that Amazon has, that are competitors and also friendly partners of ours. So it starts in seconds. There's no VM infrastructure that you have to manage. So this is a new thing. You just shove it, give it like any kind of image, give it the amount of resources you need, CPU and memory, like always, and then it will start up for you, depending on your image size. So I also want to note, now we're getting away from the fact that you need to scale based on VMs. We're kind of starting to think about, okay, I put my application into pods. Can I only think about pods? And can I only think about the kinds of pods I need to run and the kinds of compute I need for that specific pod, rather than that specific node? And this is a concept that we'll continually get back to, that in Kubernetes today, pods and nodes are very tightly bound together. You can't have a pod without a node. And this is something that we're going to try and change in the future. So if you're interested, please join us. But basically, we're trying to figure out how to abstract away nodes from pods. And now we've jump-started into Kubernetes. So in that same vein, you can have virtual nodes, which is a new feature within Azure itself. But basically, and this is something that you can run in any cloud. This is not Azure specific. I'm using Azure because I'm part of Azure. I get free credits there because I'm part of that cloud. But you can run the same kind of architecture on any other cloud provider or by yourself. So in this sense, we have a bunch of VMs. And we have wastes in here because, I mean, the Kubernetes autoscaler will do its best to make sure that all of your VMs are fully utilized. But maybe you're scaling yourself and you have some wasted resources in there in general, or maybe your pods were just overcompensating. Maybe you have too many cores, maybe you have too much memory. And then you could use this virtual node concept as a spillover area. So now you don't have to have, hey, I'm going to have like 10 nodes in my cluster because in the future I need to scale up to 10. I need to have those 10 nodes for the future for my customers. You don't have to think like that anymore. You can say, hey, maybe I just want one or two because I have a lot of stable workloads. But then in the future, I might need X amount of nodes more. But really you're talking about, I need X amount of deployments. I need X amount of pods. So that's when you can just spill over into this virtual node architecture. And you basically spill over into something, into the thing that I talked about before, ACI. And I also want to make it clear, this is like remote kind of virtual containers as a service. So what we're saying is you don't see the bounds of where the VMs or where those containers are running. You just see containers everywhere. So what it's not is multi-tenancy. There's another thing called multi-tenancy in Kubernetes that people are trying to figure out how that works. These are kind of two different things. In one, you're completely abstracted away from the fact that containers are running. In the other, you are trying to make that abstraction as a customer to your customers, possibly. And that's where multi-tenancy locally will be important to you. But these are kind of two different things in the way that I'm talking about it. So how does this work? How are we spilling over? And how are we spilling over into a random service from Kubernetes? And how does the user actually use that when they're trying to scale, for example? It's with virtual kubelet, as I mentioned before. And basically, all Virtual Kubelet's doing is talking to Kubernetes, all the Kubernetes APIs, and then the ACI APIs, and they're basically connecting and figuring out what it means to create a pod in Kubernetes, but the definition is different. So what we said, okay, if you go ahead, if a customer goes ahead and creates a pod in Kubernetes, what will happen is it's actually calling our APIs, and it's saying, create a container group in ACI. But this concept can be used in many different ways. So there's actually an IoT edge provider. You could also have your own cluster, and you could scale out into different regions within the same cluster. So these act as nodes. It just replicates what the kubelet is. So it'll act as a node, and all of those nodes can replicate a region, for example. So then in one cluster, you can have one place to manage pods from East US, from West US, from whatever regions you want, maybe even in China, which is pretty cool. The networking will not work across that, but these are just interesting ways that you can start to think about, how do I scale out into different regions and different, maybe even different cloud providers. So it's just giving you the flexibility in Kubernetes to do whatever you want and to scale out to wherever you want to go, and just have like one place to manage it all, and one control plane. It's just the same thing. So, all right. So before I demo this, I also want to talk about the ways that you specified how you scale out into nodes. And today in Kubernetes, this is another reason why I'll say nodes are too tightly bound to pods, is that you still have to be able to specify what kind of node you want to scale out to get those resources. So if you want a GPU node, you have to say in your pod spec that, hey, I want to go out to a node with a GPU resource, and this is the node name, or this is the resource. And that's where anti-affinity and affinities come in. Basically what this one's doing, it's saying, in my cluster, I want to schedule out to the normal nodes in my cluster, but if those are full, then spill out to virtual kubelet. That's all it's saying. So that's where you can use anti-affinities and affinities to basically say, I want to schedule out to this kind of node, and if that's full, maybe go here, or maybe I only want this workload on these kinds of nodes, or I only want this workload in this region, or only want this workload in GPUs. So you can use anti-affinities and affinities for that. You can also use tolerations and emission controllers. So this is important if you really don't want your developers or the people even deploying the pods to Kubernetes to really have to figure out where it needs to go. That's where an emission controller would come into play. You can use this automating webhook that will basically edit your pod spec on demand, which is pretty cool. So say if you want, in the default namespace in Kubernetes, you want all of your pods to get scheduled out to virtual kubelet, for example. This could automatically edit all your pod specs, and then it would say, hey, now you're allowed to get scheduled to virtual kubelet. This one doesn't say that you have to get scheduled to it. It just says now that I'm allowed to get scheduled to virtual kubelet. So that's another way that you can use in Kubernetes to scale out into Kubernetes in different nodes, things like that. Okay, I think I've done enough talking with slides. Now we're going to jump into demo mode, and I love live demos. I do have a video recording of it, but I want to do it live and see if hopefully the interwebs work with me. So just hold up for a second. And I have to.
Oh,
it's okay.
it's okay.
I'll hold it. I need to create my slides though. Just trying to duplicate my display, so it's just a little bit easier. There we go. Cool. All right. Okay, so I had to go in incognito mode so Azure would work with me. So So what I'm going to do is I have a simple application. It's literally this funky looking thing right here. You can go ahead and buy a Surface Book or an Xbox One. Don't actually use this website. It does not hook up to anything in the back end. But it's literally just a simple website. So you could think of this as I have a bunch of WordPress sites, or I have a bunch of sites that I need to manage, or I just have in general like a store front end that connects to a lot of stuff in the back end. So what I'm doing is I'm going to start, oh man, incognito mode, where'd you go? So I'm also using Cloud Shell in Azure. It's a fun little tool that just plugs in right into your portal, into Docs, whatever you want, and it's a shell on demand. You can even use it on your phone. So I'm using this tool called Hey, and basically it's just gonna ping this front end as many times as I said, and currently it's doing 200 pings in a second. So that's a lot, and it's running on Kubernetes, of course. And now we're going to head up to Grafana, because I think that's probably one of the best ways to show you guys what's going on. So already I can see a spike, and what I'm doing is I'm calculating the amount of requests per second per pod. So anytime there's over 10 requests per pod, I'm saying scale out, and I'm using the horizontal pod autoscaler to scale out. So this is already automatically happening. The horizontal pod autoscaler is in my cluster, and I'll show you guys that in a second. I'm not using the cluster autoscaler. I'm not scaling out in nodes. I'm just using pods, because that's just easier for me. The cleanup is also way easier. And we can see the RPS went up, and the response time took a sharp dip down, which is pretty cool. And then the RPS per pod is going up. So we're going to start to see the response time go up and down and up and down. But basically, it should scale with the responses, the requests per second with the pods. And we'll also start to see that the running pods in the VMs, it's only going to hold up at about 2. But the running pods in ACI, those are going to jump up really high, because I'm just scaling out in ACI, and I only have 1 or 2 nodes in my cluster, which is pretty great, but I'm scaling out to a cluster that would probably need 10, 20 nodes. And if I was doing that within Azure, it would take me a little bit more time than I have today, to actually scale out to this scale. But I'm doing it right in front of you in a couple minutes. So you can start to think how powerful this technology is, and how powerful like node affinities are and things like that I'm using to just automatically fill up my cluster and then scale out. And the greatest thing is right after this cluster is done, right after this demo is done, I'm going to walk away, and it's going to clean up on its own. The HPA will do that for me. It'll start to take down the pods, which is pretty great. So let's go out into Azure. Let's go here, and this is my cluster. But I'm going to refresh it, and we're going to see a bunch of these ACI containers spinning up. That's insane. Like, I just got maybe 20 of these in the last minute or two. And then Grafana will slowly start to show those metrics. It's a little bit laggy. But that's kind of what scaling should be. And I think, since I ran out of time, I kind of didn't bring the music element into the end of this. But the music element would be, before I felt like scaling was always about like craziness and rock music and metal music, and it wasn't like this calming thing. And actually, I did a talk, this exact talk at New York City Velocity, so if you want to see the music stuff, go there. But basically, the thing was, scaling should be like a calming kind of, just, I don't know, hypnotic thing. It's not something that you guys should have to touch all the time. You shouldn't be manually scaling. You should be automatically scaling, and it should be that easy. It should be customers are just saying, I need all of this, I need these products, I'm gonna hit your web server really hard, and your infrastructure should automatically and dynamically adhere to that and spin it by itself. So let's go back to the Grafana dashboard. So this is giving me RPS per pod, so that's why you see all the colors. They all will hit up at about 10. We have 12 running pods in ACI right now. And now I'm going to go here. So I also did a watch command on in my CLI to show you guys the pods that are just going in different states. And things will start to terminate as soon as there's no more load being done. So the workload might have ended, which is pretty great too. Okay, and I'm going to show you guys the HPA. And these are all just like open source concepts that I've taken and showed you guys. Well, if this is the only thing that doesn't work, that's okay with me. Do you guys have any questions? You guys good? All right. So those are just some examples in case things went awry. But I did want to mention one thing. We are looking into the fact of why do you have to today schedule out directly into a node to get those compute resources. We are looking at how we could change that in Kubernetes and how basically people could bring different OSs to the playing field. So today, your kubelet, the thing that we've mimicked in virtual kubelet has to conform to the OS that you have. We will be looking into ways to change that in the future. So if you're interested in joining us, hopefully this talk will be completely different in a year. Hopefully there's different concepts on how we scale. But please reach out. So thank you for coming in. Thank you for your time. Reach out if you have any questions. Thank you.